Hi, everyone, and welcome. So my name is Rich Spencer, and I'm the Head of Portfolio Services Technology at JPMorgan Asset Management. Now, I know if this weren't remote, this is the point at which many of you not interested in finance would leave the room, get a coffee, maybe some sort of medium quality baked good. But please don't. Firstly, because a lot of what I'm going to talk about applies to domains that have data and calculations at their core. And secondly, because the talk is only 15 minutes. In fact, it's just under that. So the talk is pretty high level, and it focuses on our journey to in-memory data grids in general, and also to our use of Ignite in particular. So for the past few years, I've been involved in a project to build an exposure calculation engine. And I'm going to use that as for examples as I talk. But in truth, the concepts are pretty transferable, as I've already mentioned. They apply to many of the systems on which I've historically worked in the finance domain. So I wanted to start off with a very quick overview of what exposure management is and what it does for those of you not familiar with this area. And you all know what a bank does, so I'm not going to start there. But here I'm specifically talking about asset management. Now, this is the part of the financial institution that uses its expertise to invest money on behalf of its clients with the intention of getting a specific return for a given level of risk. So these investments can be financial instruments such as equities or bonds or derivatives, but they can also include real assets like buildings or boats or planes. Now, specifically here, I'm talking about exposure management. And this is the diagram that you see here on the left. Within the asset management organization, exposure management is a key part of the decision-making process around those investments. So here we're taking in data from multiple different sources. The market data, static data, holdings data, and then we're slicing and dicing that to create a view of the exposure to a given vector, enabling people to look at what their risk is at any point in time. So a good example of this would be a portfolio manager who wanted to see what their exposure was to the French automobile industry, or maybe what their holdings are in US dollar denominated bonds. So at its core, what we're building here is a very big, very fast pivot table, but with lots of business logic thrown in at the same time. So the ability to actually add in custom analytics as you're actually running and generating these views. So I'm going to talk a little bit about what the challenges are of building an exposure management system. And again, these are very common to most of the systems you see built inside finance, very common to a lot of the systems that we build outside of finance. So firstly, real-time operation is absolutely key here. When a user asks a question, it needs to return the results back to the screen in less than a second in order to make the system usable. So the number of potential permutations of query make it impractical to cache all the answers to the potential questions. And also the data sets are constantly shifting, which would make this even more difficult. So realistically, we need to build a system that's able to do the calculations when the question is asked and return the data very quickly. So next, in terms of data size, I've put big-ish data here because in truth, we're not talking about the NoSQL petabyte space at this moment in time. I think potentially in the future we will be, but for the moment, we're really talking about teens of terabytes. So this is another space, flexibility. So while we can model the domain and ensure the data is stored in a format that makes sense, we can't predict the questions that are going to be asked of the system, even on day one, let alone by the end of year one, and certainly not by the end of year 10, which realistically is the kind of lifespan we're looking at for a system like this. So the system needs to have the flexibility to adapt, both at runtime and over a period of time, to support ever-changing queries against the data. Transactional support is the next thing I'm going to talk about. I'm not going to dwell on this because it's pretty obvious that with most financial systems, inconsistent views of data are simply not acceptable. Imagine how you'd panic if you were buying a stock on your personal broker account and the cash disappeared, but the security doesn't arrive at the same time. Is it a timing issue? Or has the money just disappeared? Not something that we want to be worrying about. And finally, reproducibility and auditability. So in any heavily regulated environment, and of course finance is heavily regulated, you need to be able to audit everything that was done and reproduce the inputs that fed into any decision-making process at a later date. So that's another one of our key requirements. So I guess now what you're thinking is, so what you really need is consistent reads, historic store of data, a flexible query language. So the good news is we have something that does that, and you'd be right. It's our old friend, the relational database. And so here's what exposure management systems looked like mainly in the 90s when I started work. where the ability to embed the logic within the database in some form of stored procedure made it possible to work with large data sets in real time. So this model works really well when you know the structure of the queries, as they can be defined and compiled as stored procedures. But on-the-fly queries require fiddly inline SQL embedded in the client or middle tier. However, at the time, this model worked well for many of the use cases because the efficient operations, removing all the network costs of shipping around those input data sets, made this a workable solution for returning the data very quickly back to the users. Remember, the networks back then were really slow. So this worked, and it became a popular design pattern. However, whilst it's efficient for a simple system with a well-defined access pattern, well-defined calculations, there are significant deficiencies that ultimately led to this model giving way to the N-tier architecture that you see next. So these specifically, obviously, were problems in debugging and testing. Business logic was embedded in the database, leading to reduced separation of concern. And the demise of this pattern really was hastened also by the rise of modern software engineering techniques. Focusing on CI, automated testing, and ultimately CD really did make this model unworkable. So now we skip forwards 5 years. And this, for a long time, has been where exposure management systems sat from a design perspective. So this is the next evolutionary stage. You see, the idea here was to leverage the relational database as the core data engine, abstracting the calculations into a separate layer. And this enables us to actually test thoroughly before release, as you all know. It enables more flexibility in terms of the calculations being applied, and the programming languages used are a lot easier to read than those used for stored procedures. So the diagram on this slide is not specific to any particular system. It's more of a pattern that we've seen across third-party exposure management systems and in-house exposure management systems across the financial world. But again, it's not specific to exposure management. In truth, this is actually a similar pattern that many of you will see time and time over again in your roles. So here, the functional challenges that I listed previously are separated into two very specific domains. They've been separated into data and calculations. And this is super convenient because it splits the complexity and it leaves each layer dealing with its own technical problem sets. Okay, so when you look at this, I know that strictly speaking, the caching is actually solving a data problem, but it's included solely to enable the rapid read access for the calc engine, to enable that real-time performance that we care so much about. So the other good news with this approach is it enables the engineering teams to leverage third-party software for each of the key technically challenging bits of the problem. I mean, you see here that we've got ACID databases for storage and retrieval. That's a hard technical problem. Distributed caching layers for getting the data closer to the calculation service. And you've got grids for parallelizing and distributed compute. Finally, there's always client-side logic to utilize the power of the desktop if all else fails. So the reason you see this pattern repeated so many times and the reason it's become so embedded within software engineering is because for a significant number of years, this approach has worked really well for us. It's helped us solve complex problems with bespoke calculation code, whilst leveraging open source or vendor software to reduce the technical risk and speed up the delivery. However, as the rest of the world evolves, so does finance, and with ever larger input data sets, and also increasing desire from the business to see the impact of changes in real time, there are a couple of key drivers that make the solutions based on this problem problematic for the following reasons. So database and caches. So increasing the data size means larger caches, and this becomes ever more complex and ever more challenging. You end up with larger data sets being held in memory, which increase the infrastructure needs. They also require ever more intricate memory management strategies. And in addition to this, constantly shifting data sets can make the cache expiry and update ever more complex, given that these things are now two separate components in this design. So grid computing, again, another great solution, but like anything, it depends on the exact shape of the problem you're trying to solve. Rather obviously, the calculations need to be parallelizable. And secondly, the sets of data you need to ship to the nodes for the calculation need to be small enough that that network overhead isn't a problem. So finally, on the client-side logic, I know this is an emotive topic and something that I'm not going to lecture people on. It can bring performance gains when you've got a powerful desktop machine, but it creates its own problems from a separation perspective. It makes testing difficult. It also, as firms move more towards web-based UI technologies, supporting multiple different platforms, this really is a perilous route unless it's absolutely essential. So, moving on, it's a good time to take a step back from the historic approaches and take a look at how these requirements really sit in the real world, rather than where we've traditionally drawn these boundaries, and perhaps reevaluate how we approach the problem. So in truth, conceptually, the calculations are operating on the data set. They're not completely separate in that sense. And the previous design deals with this by moving all the required input data for a function across the network and into the engine. And as discussed, this entails a heavy price in terms of time on the network and also in terms of system complexity, the larger that data set becomes. But if we flip this around, as you see here on the diagram on the left, we can achieve the same ends, but with much lower overheads. So this was the theory where we started for the design of our new exposure management system. And we started also at the same time to look at the outgoing system to see where the bottlenecks were and where we were really experiencing problems. And a couple of observations were apparent. The first of these were the calculations themselves are actually pretty fast. These are not hard mathematical problems I'm talking about here. This really in the main is pivoting, grouping, aggregation, and basic analytic type calculations. They're not massively expensive computationally. However, the data sets that were required to actually do these calculations were extremely large. So the price we were paying was actually in the network. And the output response, again, this was actually fairly small. So we started to look at and we started to test technologies that enabled us to bring the data and compute layer together, but without actually creating the tight coupling with our own analytics and code that we were so keen to avoid. Essentially what we wanted was all the benefits of the N-tier solution and all the benefits of the database solution, but without the costs that had been incurred. So this search brought us to in-memory data grids in general, and Ignite in particular, so as a potential solution to this problem. And we started to build out POCs to evaluate whether this type of product would work well for us in the exposure management space. And as we worked through this, we found that in our POCs, we were able to drop calculation times from 1.5 minutes and 3 minutes to calculate the total exposure view down to the millisecond space. So we were getting 500 to 600 milliseconds, which is an incredible speed up and gives us what we need in terms of that real-time exposure management capability. So we worked through various options with the design, and where we ended was what you see here. So Ignite is taking care of the data caching and the persistence. It's providing the compute layer, more importantly, at which we can fire and execute our custom analytics as functions. So these functions are defined with the context of the data and the calculation embedded in the code. And then at runtime, we fire them at the Ignite compute engine to create the views that we want to feed back to the user interface. So this has multiple advantages for us in terms of system designs. One, we were able to focus on building out the domain-specific features of our system with the infrastructure being left to an open source product that has thousands of developers focused on solving the hard technical problems. Two, we can encapsulate the business logic within our chosen programming language and apply all the modern design principles and engineering techniques to ensure that we're delivering with the required quality. So we could do the unit testing, the integration testing, we can embed the telemetry and monitoring that we need. And finally, performance. I've alluded to this already, but this design is around 100 times faster than the N-tier system that we were replacing. It's got fewer lines of bespoke code, so it's easier for us to maintain. And in truth, getting from a successful POC to production was a long journey of discovery. There were multiple iterations of design. We changed features, significant focus, constantly looking to reduce complexity and maximize performance. So, as mentioned on this slide, Ignite is very large and complex as a piece of infrastructure. It's not the kind of thing that you throw the CD in and let the system install and then walk away. It's got significant internal knowledge requirements, and we worked with external partners to configure it and set it up perfectly for our use case. And this took us a significant amount of time and testing, but we have got to a point where it does exactly what we need it to do. So my colleague Patrick Donovan is going to talk about some of these challenges and how we coped with them in his talk. But suffice to say, we've achieved the performance and the design goals we set out to achieve. We have a system that we're confident will support the next generation of asset managers. So, in summary, From an exposure management perspective, in-memory data grids offer an appealing feature and performance set for financial services software use cases. We've successfully leveraged Ignite to simplify our architecture, and we've gained huge performance increases by removing the cost of shipping the network around the data. So as we move forwards into the next 10 years, we hope that we have a system that will enable us to grow our business and enable us to continue to support our asset management function. Thank you.
All right, thank you for your talk. Thank you for your time today, Rich. I have a couple of questions that I wanted to fire your way. I believe hopefully will be useful to get answers to those for the community as well. My first one was, you mentioned that Ignite in memory, but in Ignite in particular stood out. Can you tell us a little about what the prime motivating factors were? There are a few options available, so how did you come to Ignite in particular?
We had a very specific set of requirements that we wanted to meet, and we started off, as I kind of mentioned, with the theory. So we wanted something that would enable us to effectively replace our database, so it had to support persistence. We wanted something that had a thin compute layer, so we needed to be able to fire these analytics as closures at the compute layer. And so we worked through the various options. We tried some non-in-memory grid type solutions, and we POC'd those. And then ultimately we found that Ignite, as we kind of went through the tick boxes, had all of the features that we were looking for, minimizing the complexity, because we didn't have to plug in additional software from that perspective. Right. So we built out a POC. We kept on amending the architecture. I mean, it was very iterative. We added in products, we removed products, and ultimately we got to the point where we were comfortable that Ignite did everything that we needed it to do. We had to build a little bit more code ourselves, actually, than in some of the earlier POCs that had various other Apache products plugged into it. But it enabled us to get to the point where we were only dealing with one open source kind of infrastructure from that perspective.
Right, gotcha. You kind of alluded to this in your answer just then, but my follow-up question was going to be, are you doing all of this in Ignite memory-only mode, or are you using persistence as well?
No, I did allude to that. We have persistence on as well. So we're using it to take in all of those data sets and persist them. So we can use this system not just for yesterday's exposure, but for historic kind of calculations and time series, because it lends itself pretty well to doing that. I alluded to the rapid kind of calculation speed that we talked about previously. Yeah. And that's particularly helpful when you start to think about life-to-date type calculations and the previous month, the previous year, because you can bring all of that together and we can calculate that in seconds instead of calculating it in 10 or 20 minutes as happened in the previous system. So we do use the persistence layer, yeah.
Right, gotcha. And you mentioned how complex Ignite is and requiring internal, some kind of internal knowledge to actually make use of certain features. How are you interfacing? So when you've built out this system on top of it, have you taken advantage of, for example, the key value APIs only, or are you using SQL to interface with it? How are you hooked up to the Ignite APIs?
So Patrick's going to talk about this in detail, actually, in his talk. So I'm not going to steal too much of his thunder. We actually started off using SQL. SQL was one of the key reasons why we picked Ignite as a product. I didn't allude to that because we've actually stopped using it now. And the reason for that was the way our data is grouped and some of the sizes of it made SQL a little bit slower than we can get to by using the binary API. So we've ended up interacting directly with the binary API and storing things as chunks of usable data from our perspective. So this isn't something we did lightly, obviously, because we were really keen to be able to use the SQL functions because it enabled us to support the application in a much simpler way. But when the performance that we needed to get to, we couldn't get to using the data modeled and supported by SQL. So we've ended up kind of doing something very specific, and that's what Patrick's going to talk through in his talk.
Right, gotcha. All right. I want to have one follow-up question on this, but I think I won't. I'll save it for later because it will go further into Patrick's talk later, and I'll ask him. I don't have any further questions for you. Is there any last words you'd like to give to the community? Any word of advice, wisdom? Because you've obviously spent a lot of time going through various aspects of using Ignite and going through all the phases. What would you recommend, or what could you say to the community, for example, for new people looking to use Ignite in their projects, from the less advice you could pass on to them, basically?
I think for us, it's been a multi-year journey to get to this point. We now have a system in production that we're really comfortable with. I think it's like any software development. The trick is to start small, to start with a POC, and to start iterating through to work out which features you need, how you want things to work. Make sure, obviously, I mean, this is, again, just simple, basic software engineering. Make sure you have all of the required testing in place around volumes, around pushing the right size of data sets in, around JMeter tests to make sure that you're actually able to push the performance to the limits with the number of users you've got, and keep on building up from there. It's been a hugely enjoyable and rewarding project from mine and my team's perspective. We're really pleased with the outcome. And if I could make the decisions over, I'd make most of the same decisions again, which is a great place to be as you kind of start to push a piece of software into production. So I'm really pleased with how it's played out. And hopefully, if people are looking to use Ignite as a product, they find the same thing.
Perfect. I did say that was the last one, but I thought of another one just then. Has your use cases expanded? So has your usage of Ignite expanded since your original POCs?
It hasn't, but the original POC was well, in terms of the original idea, it was actually fairly ambitious. I mean, if you think about an asset management business generally, the bit that I've been talking about, this exposure management function, is the core engine of the business, really. So in terms of expansion, it was already quite ambitious. I think as we kind of move through this, I think there is a possibility that we'll look at options for making larger data sets available ultimately. But that's something that's still an internal discussion at this moment in time. I could see it, once this is embedded, I could see it being something that we leverage elsewhere ultimately.
Okay.